Okay, before we get started on 7.5, um, I've got a lot of people that need to make up tests yet. Between Friday's test and the one before that, there's a lot of people who have things to make up. And I guess what I wanted to say was don't count on me like feeling I know exactly who needs to take what. There's way too many people that have been gone for various things that have missed tests. So if you are missing a test, make sure you kind of come up with a plan to make it up. And you can certainly come check with me if it works. Whether it's taking one during class time, before school, after school, whatever. Just come check with me if you have some sort of a mental plan as to what you want to do to make it up. And then we can figure out if that works or not. Because like some kids may mentally decide that they want to do it Wednesday morning or something. And that doesn't work because we have our meetings on Wednesday mornings. In class generally will work almost any time. After school, a lot of times it will work. Just check. So if you aren't sure, I can check for you, but most of you should know. And I'm partially bringing that up because we're already taking our next test next Thursday. And I don't want some of you to just get so far behind that you don't take care of it. We've only got 3 more sections to do. 7.5, 7.6, and 7.7. And I don't necessarily think next Thursday's too early. Like, these sections aren't horrible. If the last test went okay for you, this one will too. If you felt like the last test was difficult, well, then you obviously want to try to work on it to catch up and to figure out what's going wrong, because this is going to be a lot of the same things. It's just being added on to what we did before. Okay, so I'm going to split this section into 2 so that it's not too much all at once. We're going to do solving logarithms today. We're going to solve exponentials tomorrow. Okay, let's start with this one. So this is kind of the most basic logarithm one that you're going to have to solve. Traditionally, the x has been like at the end where the 3 is. And so solving that just kind of meant, plugging it in the calculator or doing it in your head. If you have to solve for inside the logarithm, does anybody kind of think they know possibly what to do? I'll just leave it all. I figured I wanted to see if anybody had thoughts on before we started it. I'll put a totally separate problem up here. I don't want to pick same numbers. I don't want you to confuse them together. How did we solve this one? The whole point of us learning logarithms was to solve for an exponent. So if you had to solve this one, you put it into logarithm form. That's what we did in 7.1. In logarithm form, this would say log base 10 of 30 equals x. And you would either do the calculator or head, depending on the numbers, whatever. So if we have a logarithm that we're trying to solve something for, we're kind of going to take the same approach. We're going to change it to the other form to solve it. The other form would be, so this was on the last test. Remember, the base is the same in both the numbers, both forms. So this one says base 5. That means it's going to be base 5. And then we've got an equal sign. And then, where's a nice bright color? None of those. Let's go with pink, sure. Strawberry. When you're switching between the two forms, these two numbers basically switch spots. So 5 to the third equals x. I know, we've had a weekend, so you probably forgot quite a few things. Are we okay on this one? Possibly, probably. Ask away if there's something up there that didn't make sense. Should I go to a harder one? Okay, this one was considered nice and easy because it was just an X right there. Like a straightforward. Now we've got X in multiple spots. Yeah.
Is on supposed to be 1? Or is it supposed to be on?
1. You're right. What the heck happened to the E? I was really lost when you said on. Yes. No idea what happened there. Oh, that's the wrong color. Pink. That's going to kill me.
Oh no. If you kill me too.
Let's cheat a little bit here. No, it's the right color pink. Come on. There we go. Now I need white again, though. Oh, yeah, 1. Okay, it went back. So we're pretty much going to use all of our properties that we learned to help us solve a lot of these problems. And you only use the property if it helps you. You don't have to use all these properties. This particular problem, the difficulty is the x's that you're trying to figure out is in multiple places. And so we would purposely use the property that combines two logarithms together. So if we have a log plus a log, we can write them as a single one with them being multiplied. So I would do x times x plus 48. I thought you had a migraine. Then get off your phone. That's the worst thing possible for a migraine. Let's see. Anybody? I don't know if these are difficult enough where if I call on you, it'll feel.
Oh,
I don't know if this feels mean to call on people for these or not.
I think it's really
What would we do from here? Like to the parentheses?
Yeah.
Sure, I can do that. So that kind of just is like simplifying a little bit along the way. I can definitely do that. On the last problem, what did we do when we were trying to figure out an x on the inside of a log? I took it out of logarithm form so that it was no longer a logarithm. And I would change it to exponential form. And multiplying the x out, you could do at either step. You're going to have to do it eventually. It doesn't really matter when you do it. So it's kind of like these two steps. The order doesn't matter, but they'll need to be done at some point. So who should I go with? Henry? How do I change it out of logarithm form on this one?
So x squared plus 48x would be
What's the base number?
the base of 10.
10. When they don't write a number, it's a 10.
And then it would be 10 squared equals
Perfect.
x squared.
Nice. Say it again? Okay. Ask away on any of these steps. If there's something up there that doesn't make sense, ask away.
Did you get the 10 squared because of the equals 2, or?
Yes.
Okay.
So taking it out of logarithm form, I guess I kind of skipped over that part. You would do the base number to the answer equals this spot. Yeah,
And why do those, I forgot what these are called.
logarithms.
Yeah, why do those go away once you factor it?
Are you talking about the brackets?
Yeah, the bracket.
Gotcha. I know you made this. You did that with your hands. I just wasn't sure. Those go away because I just didn't really need them anymore. You only write a bracket if you have a parentheses on the inside of it. So usually what you'll see is you'll write a parentheses to kind of group things. Unless there's a parentheses on the inside of that, and then they write a bracket, which is just like it's like a different kind of parentheses that it does the same thing. Yeah. If you wrote a bracket, it would have been correct. Anybody know where to go from here? Because that's kind of where we're stuck at, right? Nico, what are you doing? You were you were Googling how to do this. Excellent. So what did you find? So from a couple chapters ago, when we were doing quadratics, so quadratics like x squared, do you remember how to solve a quadratic? There was a couple main ways.
We have to undo the exponents, get rid of those.
Kinda. It's not a bad thought. I mean, like that's good logic. The issue is that this one doesn't have a power, so that's why it gets complicated. Does anybody remember how to solve a quadratic, which I'm using the word quadratic as a clue? Quadratic formula is one way we can do that. Factoring is another. I know most of you hate factoring, which is why I'm assuming you'll like quadratic formula. But those are the two main ways to solve quadratics, factoring and quadratic formula. But both of them require it equal to 0. So I would have to subtract 100 from both sides. You're not going to get this on every problem, but if you have a quadratic you have to solve, that's what you have to do, is quadratic formula or factoring. This one does factor easy, but like I said, I know a lot of you just didn't like that. So quadratic formula works. Does anybody see how to factor it if they... Oh. What two numbers multiply to 100 but add to 48? That's what you're looking for. 50 and 2. So you could do plus 50 minus 2. If you factored it. Again, I think everybody's going to skip that. Anybody remember how to do quadratic formula? Because you're going to have to remember one of those two methods. Yeah, I mean, that's pretty good if you remember the formula. I mean, I'm okay with you looking it up. But you need to know A, B, and C, right? So A is the number on the x squared, B is the number on the x, C is the number by itself. So A is 1, B is 48, C is negative 100. Do I need to take the time to do the quadratic formula with you? Oh boy, okay. We have 4 problems to do today, that's why I'm asking. Okay, negative b, and you have calculators on you today, so plus and minus, unsure. B squared, I have 0 idea what 48 squared is, and I'm not going to pretend I know. B squared minus 4AC. Do you want me to write the quadratic formula off on the side? Okay. All over 2 times 1. Negative 48 plus or minus this would be oh wait, why am I picking up my phone? I was trying to grab the calculator. Forget, I'm not at home. I do have a calculator on me. 48 squared plus 400 is 2,704. Obviously off the top of my head. Which I know the answer is going to work out nice to that. Square root of 2,704 is 52. See, I could have factored this and been done a couple minutes ago. Negative 48 plus 52 is 4. Negative 48 minus 52 is negative 100. Say it again.
I was asking where you're getting it from.
Oh, do you guys want me to explain where the 4 and the negative 100 come from?
Just where the negative 100 comes from.
So the plus and minus means I'm going to do it as 2 separate problems. Negative 48 plus 52 was my first one.
Oh.
Negative 48 minus 52 was the second one.
Got it.
Whew. A lot of work, Ben. We're not even done.
Oh dear. Oh.
So here's the problem we run into. The original question. Do you guys remember when I tried to tell you that a squared equation means we're going to have 2 answers? I know it's been a while. Well, if we looked at our original problem, we didn't have a squared, which means during the process of trying to solve this, we came up with what's called an extraneous solution. Extra answer. If I were to take both of these numbers and plug them in the original problem, this doesn't work. We can't have negative logs as problems to start with because it doesn't make sense and it doesn't have answers. Like 10 to some power can't be negative 50. So this negative 50 way at the bottom is called an extraneous solution or an extra answer. And it doesn't check. Let's just go with that. Not every answer is going to check. Did this feel like a billion steps up from the first problem?
Yep.
Yeah, understandable. If you guys remembered how to factor, it wouldn't have been. So quadratic formula isn't hard, it's just, there's a lot of steps, and I'm sure you guys forgot details. Let's put up a different one. Maybe I should have made this the last example. This one's a lot easier if it makes you feel any better. They're just different. Technically, when you use stuff from previous parts of our class, it's not supposed to make it feel harder, but I think that's what you guys were implying. And I get why. It's just. Will, why is the answer 6?
Because if it's 6, then it's log of 9, or log of base 9, 8 equals log of base 9, 8.
Perfect. So, I was guessing a lot of you would be able to look up that and just know the answer was 6 pretty quickly. The reason this question is different is because there's 2 different logarithms. And the whole point of an equal sign means they're the same. So if you have log base 9 equals log base 9, then that means these 2 things are the same. And this only happens when you have 2 logarithms equal. Basically, when you're looking at it, you know their parts are supposed to be the same. And where it's going to be difficult for you guys is this last question doesn't look an awful lot different than this question. But they have massive amounts of work difference. It may seem like a little detail, but the difference between this one and the last one, this one, the logarithms weren't equal to each other. They were both on the same side. And that's actually what makes it a lot harder. And it was equal to a number. This one, it was just log equals log. Last one. And you'll have time to work today. And I am thinking of changing the assignment because I can see that they are not going to go as fast as I expected.
Is it a 4 or 9? It's 4, right?
Which one?
Log.
Log base 4, yep. Let me, oh. Actually, if I wrote the other 4, that would look more like a 9. Now that I'm thinking, I was going to write the, like that 4, but that looks a lot more like a 9, doesn't it? Ah, whatever. It's a 4. Get glasses. Get contacts? I don't know. What? It's the whole, that's their purpose. That's like literally the only reason.
I know, I can't put them in.
Well, then wear glasses.
Oh, my glasses get fogged up with the mask.
I understand that pain. That's why I'm wearing my old glasses, because they don't fog up as much. Evan? Have any ideas? That laugh made me feel like it was a no. That sounded like a sarcastic laugh. Oh, okay. Should I call on somebody else? Or, okay, because educated guesses are good too. Good. That's what I would have done. So this fifth power on the inside makes this a lot more difficult to solve because, well, the fifth power makes the x what we're trying to get. So if we can get stuff off of the x, that makes it smaller, simpler, better. So we'll use the property to bring that out front. Excellent start. So just trying to simplify the problem very well could help. I don't like writing fours like that, Maddie. I'm sorry. Okay, now, you can't take it out of logarithm form if there's a multiplier in the front. But the reason taking this 5 out front will actually be fine and not a big deal is I can divide both sides by 5. And then that kind of gets rid of the 5, and just what it does is it makes everything around the problem smaller, and smaller and simpler is usually better when you're trying to solve.
So now we can put it in x minus 1. Or in whatever form x minus 1. See, I did this wrong. You had. I'm so
JP, question or stretching? Stretching, understandable. Okay, I'm trying to solve for a logarithm, so I'm going to take it out of log form. So 4 to the third is 3x plus 4. That's being recorded. I know. That's what
You can't really hear us.
you absolutely can.
No, listen to it.
Oh, really? Good. Okay, good. 4 cubed is 64. This is not nearly as hard as the quadratic one. Yeah, go ahead.
Wait, where did you get the 4?
I took it out of log form, so the base number went in the base spot. Oh, okay. That part's all right? Okay,
I have brain freeze.
understandable.
Brain fart, whatever.
Brain freeze sounds classier. Brain fart sounds more accurate.
Yeah.
Like the solving part of this, I didn't think was going to be a big deal for you. I thought it was the steps involving the logarithm and simplifying. Yes.
You just brought the 3 over
Uh,
on top of the 4. Or what happened to the other 3?
oh, are you talking about the 3 on the right-hand side?
How'd you get 4 cubed?
Okay, so when I have log base 4 of something equals 3, if I take it out of log form and into exponential form, the base number stays the base number, and then it's going to be equal to this answer. Or, excuse me, it'll be base to the answer equals this.
So if the 3 were a 5, it'd be 4 to the 5th.
Yes. Now, because you guys are using calculators, I wanted to point out at the beginning of the problem, you didn't have to take the 5 out front. We could have taken it out of log form from the start and it still would have worked. If I would have done 4 to the 15th equals 3x plus 4 to the 5th power, on your calculator you could have done the 5th root of 4 to the 15th and it still would have worked out exactly the same. We would still end up with the same answer at the end. So even if you didn't use the properties to try to make it smaller and simpler to start with, you don't necessarily have to, it still works. I'm only bringing that up because I know some of you are possibly feeling like these are difficult because you're not sure what to do, but basically whatever you try should work, as long as you do it correct. I don't know if I want to
10 through 16.
It's only 9 problems at each one.
Like,
Let's just do 8. What are
Oh, you guys sound like great influences.
or
Yep.
like
10 to
6.
15.
I think 6 are good. 6 is
What I'm worried about is more how long it's gonna take you. Why don't we just do worksheet B for right now? That's just, so you'll only do 9 questions instead of 18. This is going to be assigned, just not right now. I think what might be better is we'll try these for now, and then I don't know, let me decide on it. 7-5 was originally scheduled for 3 days anyway, so it's not like we'll be behind if we take 3 days.
Yeah.
So as long as you guys can get these 9 done, then we'll see how that went before we decide how to continue on.
When are we doing